Hi, and welcome back to another optics video. Today we will be learning about the basics of light perception. Before we get started, we need to recall back to our video on the spectrum of light. Remember that light can be a wave that exists on a spectrum. Today, we will focus on the rainbow region of visible light. This covers from red on the left, which has a long wavelength and low energy, to purple on the right, having a short wavelength and high energy. Let's continue with a common assumption about light. Most people assume light to have the trait of physical color. What I mean is, most people assume light inherently has color as a property, which does not depend on how humans perceive it. Look at the diagram shown. Each color corresponds to a wavelength, so how we see color does not change its physical property. While this holds some truth, it isn't the full story. For instance, consider this image. The parts where the colors meet create new colors. But isn't this weird? After all, if colors are just light waves that have different wavelengths, they should just coexist without reacting to each other. Recall from the fiber optics video I made that multimode fibers are the perfect example of this. We can pass light of different wavelengths and frequencies through the fiber and they won't interfere with each other. So if we zoom in on the cyan region, if we have light that's blue on top and light that's green on the bottom, the middle region should just form a mix of green and blue light. There's no cyan frequency being generated in that region because the waves won't react with each other. This challenges the assumptions we made earlier, as light may not have physical property of color. To understand what's really happening when we see color, we need to explore some of the biology behind color perception. This is a simplified diagram of an eye. The rightmost part is called the lens, and this allows light to enter our eye. The next part is called the retina, which is a thin membrane at the back of your eyeball highlighted in yellow on the diagram. One type of light detector found in the retina is the rods. These are responsible for helping you see in low light conditions, though not particularly with color. Another detector found in the retina is the cones, and this is the key to seeing color. Both detectors send signals to the brain based off the light let in by the lens through the optic nerve. Before we continue, on the screen is a quick recap of what we just learned. Feel free to pause to review. The cones are interesting because they come in three types, with each type detecting either green, red, or blue light. There isn't a detector that can see all colors. The rods, on the other hand, can't detect color and only can detect if there's light or not. This is why in the dark you see black and white only. Going back to the cones, if red light passes through your lens and gets picked up by the cones, they send a signal to your brain telling them that the color is red. Likewise, if the lens picks up green light, your cones send a signal to the brain that it's green. The same thing happens for blue light. But what if it's none of those things? What if true cyan light passes through your lens? That is, with the cyan wavelength, which is around 490 to 520 nanometers. Well, you don't have a detector for the color cyan, but cyan is a little blue, and it's also a little green. Your blue and green cones both send some small signals to your brain, and so your brain learns that cyan is created by both some blue and some green. If we replace the cyan color with the correct combination of blue and green light, our brain receives the same combination of blue and green signals from the cones, and we think we're seeing cyan when it's really just blue and green light together. As you can see, both light sources provide the same signal to the brain, thus tricking us into thinking that blue and green make cyan, when in reality the light waves are completely different. This makes it a lot easier to make color TV, as TV manufacturers only have to use 3 different color LEDs in order to create every single color that we can see. All it takes is the adjusting of the brightness of each of these 3 lights, and our brain is tricked into seeing all sorts of beautiful colors. So I hope this video cleared up any misconceptions about color perception and taught you how humans see colors. As always, thanks for watching, and I will see you in the next video.